So today we will be covering sliding window. This is a day 3 and we will be covering today the sliding window. Okay, so let's see the definition. The sliding window is a technique used to solve patterns that involve the contiguous segments or subarrays, right? So mostly for subarrays we will be using sliding window, and it can be applicable on arrays as well as on strings, right? So basically it involves maintaining a window. So let's say we are given some array 1 2 3 4 5 6 7, and we need to find some sub array that sum equal to, let's say, k is the target. So basically in this pattern we will be maintaining a window. Let's say this 1 to 3 is a window of size k, where k is 3, right? This is the window of size 3, right? The next window can be 2 3 4, the next window can be 3 4 5, like this. So these should be in the continuous manner, right? After that 4 5 6 5 6 7, like this, right? So this is what we call window, and it can be defined by 2 pointers. So first pointer can be here, like if we see this window, right? So starting pointer will be here and end pointer will be here, right? And we will be moving the pointers for the next window. Let's say for the next window this pointer will move to this one, right? And this 3 will move to this 4. Now this is the window. So in this way we will be maintaining the window using 2 pointers. Usually start and end that slides over the input data, right? So the window can either be fixed size or variable size. So in some question they may ask the window of k size, the size is given, right? In some questions they may ask give the size of the window, like we need to return the size of the window, where we were given some input. Let's say sum is 10, so we need to find a subarray with sum 10 and we need to return the size of that subarray, that is the size of window, right? So this is 2 type of question. So instead of recalculating everything for every window, it efficiently updates result as the window moves, right, forward by adding the new element and removing the old element, right? So if you see this question 1 2 3 4 5 6, right? If we are checking this window, right, the sum is 6. For the next window, instead of calculating the sum of all the elements 2 3 4, we can do one thing. We can remove 1 from this. 6 minus 1, that is 5, and add the new element, that is 4. So we will get the sum 9, correct? Yeah, okay. So this is the way we will be removing the old element and adding the new element. After that, where it can be applicable, the sliding window applies mainly when you need to find this something about subarrays or substrings of the contiguous elements, right? Or when we want to calculate or track a property over a range that moves forward step by step, right? So the problems involve sums, counts, maximum or minimum frequency of elements inside a window. Like I said, we need to find the sum or we need to find the size of the subarray, right? So fixed sized windows will be there. Let's say for example find the max sum of the subarray of size k. So we need to find the maximum sum of the subarray with size k. We will see this question. Okay, how to apply sliding window pattern? So there are generally 2 types of sliding windows. One is fixed size, in which the window size is fixed, right? As in this question the size is given, right, k, and we need to find the maximum sum. This is the first type. The window size is fixed. Let's say 1 2 3 4 5, we are given size as 3, right? And we need to find the maximum subarray with size 3, whose sum is the maximum, right? So it will be this one, right? 3 4 and 5. So this is the maximum sum of the subarray. So in this the window size is fixed, right? So these are the example. So initialize sum, frequency map, and so on we will see in the questions. And the pattern is given, like we need to move one element forward and remove the last element and add the new element, correct? After that, the second type is variable size sliding window. Okay, so in this basically some condition will be given. Let's say product is given, or sum is given, and we need to find the subarray with this condition. Okay, let's say sum is 10, so we need to find the subarray whose sum is 10, right? And we need to return that size. So we will be using 2 pointers, start and end, move and forward to expand the window until a condition is met. Okay, so we will be checking the condition and moving the element. So these are the steps we will see in the questions. How to check which type of sliding window can apply to. Okay, so basically we will be looking for these clue. Okay, the problem deals with subarray or substring. This is the common. Okay, now we need to find something like maximum or minimum sum of the subarray of size k. This is fixed size. Okay, fixed size is given and we need to find the sum of subarray, right? The second type is, in this we can apply the fixed, right? The second is longest or the shortest subarray meeting some criteria. Let's say we are given the sum and we need to find the longest or the shortest substring or subarray. This is the second type. Count of distinct elements or frequencies in substring or the subarrays, right? Any problem involving continuous or the contiguous segments. So basically 1 2 3 4 5, like this is the array, right? In some question they mention you need to find the continuous elements, right? So these are the continuous elements, these are the continuous elements, right? So these are the basically a window, we can say this is the window. We can apply the sliding window. We will check if we can apply, then we will move forward with the sliding window, right? So let's move forward. After that, benefits of sliding window. Efficiency. First is efficiency. Now it will reduce the time complexity from n square to the n. Let's say if we need to find the subarrays, what we will do, the brute force approach, we will use the nested loops, right? We will use the nested loops, correct? One for this thing and another for the next elements, right? So it will find all the subarrays, but it will take n square time complexity, right? The sliding window will reduce our time complexity to O(n). Here we will be using 2 pointers, that is one for the starting point and one for the end point of the window, right? Okay, easy to implement once understood. So you will understood surely about this after this session. Memory using constant or the linear extra space. Okay, so these are some basic benefits of the sliding window. I hope you get the logic. Okay, then let's move towards the question. First question, maximum sum of distinct subarrays with length k. Okay, so what we are given, we are given an integer array nums and integer k, that is the fixed size, right? Find the maximum subarray sum of all the subarrays of nums that meet the following condition. The length of the subarray is k, the fixed size is given, right? Windows size is fixed. After that, all elements of the subarray are distinct, so there are two conditions, right? So first condition is fixed size is given. Second condition is elements should be distinct. Okay, no duplicates, no duplicates. Okay, after that, return the maximum subarray sum of all the subarrays that meet the conditions. If no subarray meet the condition, return 0. Okay, let's see the example. Okay, so this is the input given, that is 1 5 4 2 999. Okay, and size is given 3. So window should be of 3 size. Okay, now we need to find the subarrays, and output is 15. How it is calculated? So see, first subarray can be 1, 5, 4, right? The sum of this subarray is 10, correct? After that 5, 4, 2, the sum is 5, 4, 2 is 11, right? After that 4 to 9, 4 to 9, the sum of this is 15, correct? After that this 299, but it doesn't meet the condition, right? Elements should be distinct. Here 9 is there, right? So duplicates are there, so we will not take this subarray. Same with this 999. Okay, so maximum sum is 15, so we will return 15, correct? You understood the problem? Now how we will do this? See, the first thing is we need to maintain a window. Let's write it here. Maintain window of size k, and there is one more condition: elements should not be duplicate. Should not be duplicate, right? So these are the two conditions for our window, right? We need to maintain a window of size 3 and elements should not be duplicate. If duplicates are there, then we need to change the window, right? So what we can do, let's write it here again: 1, 5, 4, 2, 999, right? K equal to 3. What we will do now? See, one more thing. Okay, so duplicate should not be there. What we will use? We need to use some data structure, right, to check if duplicates are there or not. So we will be using set. We will be placing our Windows elements in the set and check if new element is already in the set, then we will not consider that. Or what we can do, we can remove the element from the last of the window. Okay, let me show you. Okay, we will start with this. Okay, first pointer, and we will be maintaining our set 1. We can add in the set, and we will also calculating the sum. Okay, currently it's 1, then it will move to the next. 2 pointers will be there, the starting and the end. Okay, so end pointer will move further, so it will go to 5. Again it will check if 5 is present in set or not. It's not present, right? We will add it, and we will add in our sum, that is 6 now. Again it will go to 4. It's present in set? No, it's not present. We will add it here. We will add it 4, right? We got the sum 10, right? Here till here the size is maintained, right? It's 3 only or less than 3. And the second thing is element should not be duplicate. In this window no element is duplicate, right? So the first sum we got is 10, correct? After that, what about next window? For the next window, now this element, this pointer will go to 2. Now it will check the size is greater than k, right? So we will remove the element from the last, that is from the left. Okay, so we will remove this. We will remove from the set. We will add 2 here. Okay, so it's not duplicate, so we can add it, right? After that, again, now window is 3 only. This is the window, right? We removed this last element. Now what is the sum? Sum is from the sum, that is 10. We will remove the last element, that is 1. It is 9, and add the this new element, that is 2, right? In the theory also we mentioned that we will remove the element from the last. Where is it? Here it is. Adding the new element and removing the last element for maintaining the window, right? So we will remove we will remove 1. We removed 1 and add 2, right? So we got the new sum as 11, right? So 11 is there. Now it will this pointer. Now the pointer, starting pointer is at this point, end pointer is at this point. Now this will move further, right? For the next iteration it will come here, right? Again it will check this is greater than the size, right? So it will remove the last element, that is the 5. It will remove 5, add 9. It will remove 5 from the sum, that is 11 minus 5 and plus 9, right? So it will be 15, correct? Yes, 15, right? Till now it's clear. Shall we code now? So this is the question. Okay, so for the duplicacy we will be maintaining set, right? After that we will be having sum, in which this is basically the current sum, or we can also write current sum. And what else? A max sum also, right? Initially both will be 0. After that we will be having one starting point and one end point, right? Let's say left equal to 0. After that we will be using for loop. This will be right, let's say equal to 0, and right is less than what? This nums.length, right? And then rigst plus plus, correct? So 2 pointers are there, one is left, one is right. We will be moving right till when? Till window size is less than k. Okay, so while we are having two conditions, one is duplicacy and one is size, right? So we will check if dot contains what? Nums of I, that means duplicates are there, or what else? If size set dot size is equal to k. That means if duplicates are there or our set size is equal to k, in this case what we will do? We will be removing the elements from the left side. Set dot remove nums of left, right? And from the sum also we need to remove, that is the current sum, what? Nums of left. And we will do left plus plus. Okay, our left pointer will move to the next point. Then next, if it's less than the size and it is not the duplicate element, then what we will do? We can simply add it in our current sum, right? Current sum nums of, right? Okay, I need to write. After that we will add it in our set. That's it. At the end we will check if set dot size is equal to k, then we will update our what? The max sum. Okay, max sum, yes, max sum will be equal to math dot max what? Current sum and max sum, right? At the end we will return this max sum. Let's run it. Left, okay, accepted. Let's submit this. Wrong answer, for which case? Okay, we should use long here. Okay, it's accepted now, right? Okay, so let's see this again. Let me copy this code. Example was 154 299. Okay, so what we are doing, see, we are having conditions. First is duplicates are not there. Okay, so for that we are using the set, correct? And after that we are maintaining a current window sum, that is the size of the subarray, right? So for that we are using this current sum variable. After that we are having one variable, that is maxsum, which will store the maximum sum of all the subarrays, right? From all the subarrays, right? After that we are having two pointers, that is left and right, correct? Both initially will be at this first position, right? After that what we are doing, see, we are leave this while condition for now. What we are doing here, we are basically adding the element in our current sum, right? That is, we are adding 1 and we are adding in our set also, right? We added 1, right? After that it will check if set size equal to k, then we will update our maxsum, because we need to maintain the window size of k. When the window size is k, then only we will update our maxsum, right? Correct? So till now it will not be applicable. Next this right will go to this 5. Okay, now the current sum will be plus 5, that is 6, right? Again this if condition is not satisfied, again it will add in a set, it will move to the 4, again it will add 4. Now the sum is 10, right? The sum is 10 and the window size and the size of the set is k, right? Now it satisfied the condition, correct? It will update the maxsum now. Maxsum initially was 0, now 10 is greater than 0, it will update 10, right? Till this point everything is clear. Okay, so what's next? So till now we are having the first window, right? We are having the first window, we got the sum 10 and we updated the maxsum using this if condition, right? So now the maxsum is 10. Now it will go to the, this right pointer will go to 2, correct? Now it will check if duplicate is there. No, it's not there, right? Again the next is if the size is equal to k. Yes, the size of set is equal to k. In this point we will remove the last element, right? Because one window is already formed and we are adding new element, so we need to remove the last element, correct, for checking the new window, right? I hope you got this point. Basically what we are doing, we are removing the element after checking this window. This first window we have checked, we have updated our maxsum. Then in the next iteration, when right pointer will go to the next variable, then it will maintain the window size of k, right? At this point we are removing the last element. Got it? In this while loop we are removing the element from the set, we are removing 2 and we are removing the element from the current sum, that is 10 minus 1, it's 9, right? After that we are incrementing our left pointer, that means our left pointer will come to here, that is the new window, right? This is the new window. After that again we are calculating the sum, we are adding the element in our set and we are checking if it's greater than maxsum or not, right? I hope you got it. Okay, that's it. After that it will go to the next pointer, it will go to 9, again it will remove the last element, right? That means the 5 2, sorry, not 2 here, not 10, it's 4, right? It will add 2, then after removing 5 it will add 9, we will get sum as 15, we will update the maxsum as 15. After that at the end, when it will come to this 9, again it will check this condition, right? It will check this condition. set dot contains num, right? It contains, right? 9 was already present. So what it will do? It will remove the element, the left element, that is the 4. It will remove 4. It will remove from the current sum. This is the current sum. It will remove 4. It will be 11. Again it will check, and it will update the left pointer. Left pointer will come to here. Okay. Again it will go to while loop, check the condition if duplicate is there or not. It's there, right? 9 is there. Again it will remove the leftmost element, that is 2. Remove from the sum. It will become 9, and update the left pointer, that is it will go to 9. Again it will check if it's there, duplicate is there or not. It's there. Again it will remove 9, correct, and remove from the sum also. It will be 0, and update the left pointer to this. Right now left and right both are pointing to the same element, right? Now it will not go to this while condition. It will go to this logic. In the current sum we will add 9. In the set we will add 9. So currently in the set the only element is 9, right? We removed all the elements, and the current sum is what? 9. So will it go to this if condition? No, it will not, because the set size is not k, it's less than k, so it doesn't satisfy the condition. And same with this 9. It will remove this 9 also, add 9. Again the condition is not satisfied, right? Can we more optimize it? No, this is basically taking n time complexity, right? So we can't optimize after this. We are not using extra we are using extra space, but that should be necessary for this duplicacy. This should be constant only. We are maintaining the size of k, so the space will be of k and the time will be of n, where n is the number of elements in this num. Okay, so shall we move to the next question? The next question is longest substring without repeating characters. Okay, so we are given a string s. Find the length of the longest substring without duplicates characters. It's something same, right, with the last question. Let's see the example. We are given AB. Let's copy this. So we are given what? The string as A B C A B C B B, and we need to find the length of the longest substring without duplicate characters. Okay, so substring, we need to find substring. Okay, with this only we will get to know that we need to applying the sliding window. Okay, substring or subarray, anything will be there. First try to apply this sliding window. Okay, so we will check now, is this sliding window applicable or not? See, duplicates, two conditions are there. Duplicates should not be there, right? And we need to find what? Find the size. Now here fixed size is not given. We need to find the size, right? Condition is duplicate should not be there. That's it. How can we do this? See, we will be having two pointers, right? Left and right. Left and right. So in the first iteration, same like the last question, we will move our right pointer, and duplicates are there, so we need to maintain one data structure. Let's say set. Okay, we will add A here, then we will move to B. It will check if it's present or not. It's not present, then we will add B, and side by side we will be maintaining our size, right? Currently it's 2. Then it will go to C. It will check duplicates are there. No, we will add it. Size is now 3. Again it will go to A. Now it will check if duplicate is there or not. It's there, right? It's there, so we will be removing elements till this duplicate is there, right? As we did in this last question, we are having one while condition, right? While condition, let me show you here. We are having this while condition. It is checking till duplicate is there, we will be removing the element from the left. Same we will do here. Okay, so it will remove A, right, from the left side. We will add A here. Now the size is 3 only, right? Again it will go to B. Duplicate is there, yes, it's there. We will remove this, add this, size is 3 only. It will go to C. It will check C is there, duplicate is there. We will remove this, add C, size is 3 only. Again it will go to B and B, duplicates are there, right? So for B it will do what? It will remove first A, right? Still duplicate is there, right? It will remove B also. Now duplicate is not there, we will add B. Now the size is 2, right? So max will be 3 only, right? So at the end we will return 3. Understood everyone? The same thing like we did in the last question. Okay, so let's code this then. Okay, so let's take n as the length of this string. After that int max length will be there, that will be initially 0, right? After that we need to maintain a set, right, for duplicacy. Hash set of character type, yes, let's say set equal to new hash set, right? After this what we are doing, we will be having one pointer that is left. The second pointer will be in for loop, right, equal to 0, RIGST as less than what, n, and right plus plus. After that what we are doing here, we will be having one while loop, right? Same we will do here. While duplicates are there, we will be removing elements from the last, right? So set dot contains what, as dot caret right, correct? Till duplicates are there, we will be removing elements from the left side. So set dot remove s dot caret left, okay, and we will be incrementing our left pointer. That's it. After that, if this is not the condition, what else? We need to add the size, right? So first we need to add this in the set dot add s dot caret right, and we can have one more variable, that is current length, or we can update it here only. Let's see how. Equal to math dot max length, and what is the size of the window? That is right minus left, right? This will be the size of the window, correct? Right, GST minus left plus 1. Okay, let me explain this. See, we are having one pointer here and one pointer here. What is the length of this? This is left, this is right, correct? It will be right minus left plus 1. It's 0, 1, 2. So it's 2 minus 0 plus 1. It will be 3, right? The size of window is 3. That is right minus left plus 1. So this is how we will get the size of the window. Okay. At the end, we can simply return max length. That's it. Let's run this. Submit this. Accepted. So understood. Shall we move to the next question then? Okay. So the minimum size subarray sum. We are given an array of positive integers and a positive integer target. Here target is given. Return the minimum length of a subarray whose sum is greater than or equal to the target. So two things are given. First is what? Target is given. Target given. We need to find the what? The subarray or the minimum length of subarray. Okay. Minimum length of subarray whose sum should be greater than, right? Greater than and equal to, yes, sum greater than equal to target, right? So target is given. Window size we need to find, right? Fixed window is not given. We need to find the size of the window, correct? If there is no subarray, return 0. Okay, so let's see the example. So we are given the array 2, 3, 1, 2, 4 and 3, right? We need to find the minimum length, that is the size of subarray or the window with sum greater than or equal to target. Target is given, that is 7 in this case. Okay, so we will start with the 2 pointers, right? Initially at the 0 index, left and right. We will move further. The right one, okay, right one will go to here. Now here duplicacy is not there, right? So we will not be maintaining the hash set. Duplicacy is not there, so extra data structure is not needed, right? So it will move to the next pointer. Now it will check the sum. It's 5, right? Sum is 5. Again it will move to the next pointer. The sum is what? Sum is 6, right? Again it will move to the next pointer. The sum is what? 8, right? The sum is 8. Again it will move to the next pointer. The sum is 3, 6, 8. Now the sum is greater than target. Now we will check the size. Okay, it's 4. Size is 4. Okay, till now. After that it will move to the, now it's greater than, we got our condition. We will be removing the element from the last. Why? Because we need a minimum size, right? So this was the window. We will be removing the element from the last. Okay, we will remove 2. The sum will be 6, right? Now pointer is at here and here. Again it will add 4. 6 plus 4, it's 10, right? What is the size? The size is again 4 only, right? So again we will remove the last element from the left. 3, we removed this. Okay, now what is the size? It's 7. Again it satisfies the condition. Now what is the size? Size is 3. We will update 3, right? This is the window. Okay, again it satisfies the condition. Again we will remove the last pointer, that is 1 minus 1. It's 6 now, correct? Again it will add the, this is the window. Okay, it will add 3 plus 3, it's 9. Okay, it's basically it's same, size is same. So it will remove the last element, that is this one. Okay, so the sum is now 7, right? It satisfies the condition. We will update the size, that is 2, correct? So we got our answer as 2. So what we are doing here, first we are having 2 pointers, left and right, correct? Second thing is adding the element, adding the element to sum. And third thing is, if sum is greater than what, or equal to target, then what we are doing, removing the element, right? Removing the element from left. Why? Because we need a minimum size window, right? So we should remove the element from the left so that we can get small number of elements with some target. Okay, this one. Remove the target. After that what we are doing, we are updating the window. Okay, window update when when satisfy the condition, when satisfy the condition. Okay, I will write the code. In the code you will understood it. That's it. After that, what we are doing, we will we are removing the element from the current sum, right? So current sum, let's write the code. Understood till this point? So let's write the code then. So we need to maintain a minimum length. Okay, so let's initialize this with the maximum value of integer dot max value, right? After this, we will be having one pointer that is left, and the current sum will be there, right? After that, for loop will be there with the second pointer that is our right, and right should be less than nums dot length RIGTH plus plus. After that, current sum, we will add the element in the current sum, that is nums of right. After that, we will be checking the condition. If it's greater than the target, the current sum, right, we will be removing the element from the left. Current sum is greater than equal to target. What we need to do, we need to first check the condition. If right minus left plus 1 is smaller than min length, then we will update the min length. Min length is right minus left plus 1, correct? We will be updating our min length, and after that, from current sum, we will be removing this, right? Nums of left, and updating our left pointer. That's it. At the end, we will be removing returning what? See, we need to check if the min length is equal to this max value, then we need to return 0, like here we mentioned, right? Otherwise, we need to return the minimum length, whichever we have calculated, right? So we can use a if condition also, but I will be using ternary operator equal to what? If it's not equal to integer dot max value, then what we need to return? The max length, right? Otherwise 0. Let's run this. It's current sum min length. What I'm doing? Accepted. Let's submit this. Okay, submitted. It's understood. Or do you want me to dry run this once? Dry run. Okay, so what was the given? 2 3 1 1 2 4 3, right? So target was given as 7. We need to find the minimum subarray, the length of subarray. Okay, so initially we are having this minimum length, which will calculate the overall minimum length, right? And we are having one pointer left, one pointer right, and the variable current sum, which will calculate the current sum of the window, right? After that, we will add our current element, that is initially both will be here, the left and the right, right? After that, we are adding okay, the element in the current sum, that is 2. We added 2. Now it will check if the current sum is greater than equal to target. It's not. So what we are doing, we are simply moving to the next pointer, that is 3. We are adding 3. It's 5. Again it's smaller. Again we will move, right? It's moving here, right plus plus. So we will add 6. Again it will go to 2. We got 8, right? So now our pointer, the left pointer is at first point and the right pointer is at 2, correct? Now it satisfies the condition, right? Current sum is greater than equal to the target. Now what we will do, we will update our minimum length. Okay, minimum length. So we will check the condition if this the size of current window, that is 1 2 3 4 4. Okay, 4 is smaller than the minimum length. Minimum length was initially what? The max value of the integer, right? That is, I think, 2 raised to power 32, 31. Okay, so it will be smaller only, right? So we will update the minimum length, so it will come 4 here, right? After that, what we are doing, we are removing the last element from this window, that is 2. We remove 2, 6. And what we are doing now we are incrementing the left pointer, that is, this will come to here. Again it will check this window satisfy the condition or not. The current sum is 6, right? It is not greater than or equal to 7, so it will move to the next pointer, that is right plus plus. Right will come to here, it will add 4, it will come 10. Again it will check satisfy the condition, yes, satisfy the condition. Again it will check if the window, the size of the window is smaller than the min length. No, it's not smaller. So what we will do, we can simply remove the last element, right? Last element we will remove. This left will come to here, right? Now what is the window? This is the window, right? So this is the window. The sum is, we remove 3 and we what? The sum is 7. Again it satisfy the condition, right? It satisfy the condition. Again it will go to this. Now the window size is 3. It will update 3, right? The right minus left plus 1. Right minus left plus 1. This is the window size, right? The 0 1 2 3 4 4 minus 1 2 2 plus 1. It will be 3, right? It's smaller, so it will update the min length. Correct. After that, again our ultimate goal is to minimize the length of the subarray, right? So we will remove the last element from this, the leftmost. So we removed 1. Now it's 6, so it doesn't satisfy the condition, right? It's not greater than or equal to 7, so right pointer will move here, it will go to 3. And now the size is 4 plus 3, it's 9, right? It satisfies the condition, but it's not less than this min length. So again it will remove the last element, that is 2. What is the count here now? It's 7, right? It satisfies the condition, so the size is 2. Now we will update this 3 to 2 here, right? That's it. Again it will remove 4. Now the it doesn't satisfy the condition, while loop, right? So ultimately we will get min sum as min length as 2, right? Understood? Test case, different test case you want, or let's see this one. We are given the input as 1 4 4, right? Target was 4. It will start from the first index, right? Left and the right pointer will be here, left and right. After that, in the first iteration, this right will move to the next pointer, right? It will move to the 4. Now what is the sum? Sum is 5. It satisfies the condition, yes. Target is less than or equal to this 5, right? So the sum is equal to or greater than this target, yes, it's satisfied, but we need a minimum size, right? Minimum number of elements. So we will remove the last element from the sum. We will remove the last element 1. It will come 4. Now again it will check if condition satisfy, yes, it's satisfied. Where it is checking? In the while loop. See, in the while loop what we are checking, if current sum, that is initially it was 5, right, is greater than equal to target, yes, it is greater than, then what we are doing, we are first updating our min length, that is the size of the window, that is right minus left plus 1. Here in this case it's 2, right? 1 and 4, so we will get 2 here. And after that we are removing the number, the leftmost, right? So we have removed 1 from here, right? This is the code for removing and updating our left pointer. It will go to 4. It will come to here, right? Now what is the sum? Current sum is 4. Again it will check in the while condition if it's satisfied or not. It's satisfied. Again it will update the main length. It will come 1, right? Because this left and the right pointer pointing to the same element. So we will get 1. After that it will go to 4. Again we will get the size of 2. So it will not update.